Modern medicine is really good at keeping us from dying. But life after a critical illness is often debilitating and chronically painful. That's why I study a special white blood cell called the macrophage. If you think about our bodies as apartment complexes, the macrophage is the building manager. A good building manager keeps the space functional and safe for the people inside, like replacing a broken light bulb or calling a professional plumber. Macrophages do this too. They patrol every organ in the body, fighting germs, healing wounds, even killing cancer. But what's most important is that they're performing the right function for the right task. Otherwise, they start to cause problems like protecting a tumor from chemotherapy or attacking your heart when it's trying to heal. Clinical research shows that how completely a patient recovers from diseases like infection, heart attack, and cancer depends on whether their macrophages will work for them or against them. So understanding how macrophages behave is key to building a holistic picture of our health. But what's so hard about this is that we can't see what they're doing inside our bodies. What's more, each person's macrophages are uniquely programmed to that individual. My project is to build a model that predicts how healthy and how functional macrophages are. How I actually do this is by performing experiments to measure each macrophage function. For example, I'll feed fluorescent bacteria to macrophages and then measure how brightly they glow when they gobble them up. Or I'll put macrophages on damaged skin and track how the tissue repairs itself. I can even throw macrophages at cancer and watch them disintegrate a tumor. If I perform these experiments across a range of biological environments, I can generate enough data to train a statistical machine learning model that can forecast these macrophage functions in any environment for any patient with any illness. And what's amazing is that with this model, I can statistically link a patient's macrophage functions to their clinical outcomes, like how well their heart repairs, or how poorly their lungs scar, or even if their cancer will return. This model can be used as a platform to test drug toxicity, as a guide to interpret lab data, or even as an insight into how your body responds to an injury. So imagine going to the doctor and having a lab test that not only tells you your risk of getting a heart attack, but how well you would recover from one. The future begins with understanding who's running the building inside our bodies.